So just a little plug for the paper which Sergio and I have written, and it's published in Urban Geology in Wales 3 if you're interested in reading a little bit more on the geotechnical background to this. And finally, just an acknowledgement obviously of the parties involved, the Welsh Assembly Government who sponsored the scheme, Nutra who the designers of the bridge, Chris Head and team, Heide who the geotechnical consultants, Alfred McAlpine who constructed it, now Carillion, and Michelle who were the Cat 3 checkers. Thank you very much for your attention.
Ian Draycott, I'm with Halton Borough Council. Question for Jonathan. I'm intrigued with the skewed nature of the deck, but noticed that there was only 15 millimetres torsional differential movement. Did the relatively flexible nature of this deck mean that you didn't actually attract a great amount of load on the obtuse corners?
The concern was that the obtuse corners normally attract load on the skewed decks, but as you say, the flexibility of the deck actually meant that it wasn't a significant problem. The attraction of that moment to the corners, we were worried that would possibly cause that torsional effect, but in fact the flexibility meant that it was okay.
Quick question: form of contract. Presumably it was an NEC contract. I was very interested about the risk allocation to the employer for the ground conditions. Can you just tell me which sort of contract it was, please?
It was an NEC contract. I'm looking to my colleagues, but I'm not certain we can help. Chris Head, who's obviously got credit for the talk tonight, was due to be doing the talk. He was the main guy involved in the design and the project, but unfortunately he's gone to Malaysia on holiday. Hence me being here and filling in. But I think someone may be able to help behind you.
Yeah, I'm Mike Vitkovich. I was the project engineer for this scheme for the Welsh Assembly Government. The decision, because of the detailed design work that had gone in and the great confidence that our designers had in terms of the settlement of the bridge, put us in a position of saying, well, we can't expect a contractor to take on all this information, because the rumours were out that this was skin on the rice pudding and it was going to be a difficult job. So we knew that it was going to attract a lot of risk if the contractor put that in his price. At the same time, the detailed design of the bridge and the relative simplicity of the roadworks favoured an option B. So that's the way we went. Straightforward option B, everything quantified, and a clause putting all the risk for the ground conditions back onto the employer.
It's Rob Evans, Waterco. Fascinating talk, and I think it just shows the value of good engineering, saving the client a lot of money overall, instead of installing 50-metre long piles. But I just wondered, is there any long-term issues with creep with that material?
Yes, we took that into account. In fact, the back analysis of the settlement post-construction using empirical methods suggests another 10 mil will take place in the next 60, 120 years. So, but there is enough scope there to take a bit more. But based on Berlin and Burbage, which is a case history of many bridges on granular material, suggests about another 10, 15 mil will take place in a long time.
It's a question for Sergio. The ground conditions at this site seem exceedingly unusual. Did you find any case history information for similar ground elsewhere in the world that was useful?
No, when we started this in 2001, and the first thing was to go through all the available literature. We tried everywhere. We tried the ICA library, and there was absolutely nothing at all of similar. I mean, there was some silts somewhere else. Some of them are clay silts, but they were not exactly the same kind of silts. The only example was the Corwen bypass report, which had early on, just the same ground really, but But no, there wasn't. It was quite unique in the world in terms of material.
Here, Rob Owen, Anglesey County Council. Just a simple question. It's how did you check the integrity of the shear studs?
In terms of the design, or in terms of the
construction?
The construction, it was a standard test. In fact, in the photograph, if you looked, you could see one knocked over. Man hits it with a big hammer.
Hi, I just wanted to ask whether, obviously, with the sheet pile retaining wall along the front there for the scour protection, quite a significant length, whether that was ever factored into the modelling pre-construction in terms of skin friction that would be picked up through those silts on the sheet piles, and whether that would contribute to either the carrying capacity or the reducing the settlement for the overall abutments.
Yes, it did. I mean, the first analysis was using a flexible slab and ignoring the contribution of the sheet pile wall. Then that we use a Plaxis to the model, financial model, which confirmed that the front part of the sheet pile would settle a lot less than the back. And that's one of the slides illustrated that there was about 70-75 mil on the back of the structure, about only 48 mil on the front, which, yes, it did create a significant resistance. And that was in 2D. I mean, we obviously didn't do a 3D model, but I'm sure that a 3D model would have shown that that contribution was quite significant because along the whole front of the trapezoidal shape. So possibly we have ended up with maybe 20-30 mil, but it's quite expensive to do a 3D model of finite element with Plaxis.
But the concern to some extent was the opposite.
Yeah.
That it would actually increase the settlement because it would disturb the silts.
Yeah.
And in fact, as you know, was suggested, there were all sorts of suggestions that there would be significant problems with the driving, the piles and what have you, none of which was actually true in the end. So yes, it actually had the opposite effect, which is what we modelled.
Question for Sergio, really. In the introduction, you described, well, in the trial, you looked at pore water pressure, and when you talked about the early testing, you said there was significance about topping the boreholes back up with water. Do you think if you ever had a dry summer and desiccation, there would be any issue with this? If the silt dried out at all?
Well, there is a hydraulic continuity between the gravels in the river and the silt beneath. So that's very unlikely. I mean, the water will have to go down a long way before that is an issue. No, I don't think that is within the current climate. I think that's unlikely, but obviously in the long term. I mean, the analysis was always elastic, so water really didn't come into the picture. But yes, there is something that obviously of big concern. Yeah.
Thank you. The question for whoever designed whoever was looking at the options for the pile design. We talked about the silts being greater than 50 metres deep. In terms of a pile design, were we looking at founding them on the gravels, or was it a friction pile of silt?
Well, we didn't know, but the concern was that there would be problems with providing adequate skin friction because the piles were potentially so sensitive and would be so disturbed by it. So we didn't get that far down the route because we weren't sure how we would design them, basically. So one option was to remove that, was to somehow take the piles down to the gravels. Either way would have been, you know, you're right. I mean, in practice, from the sheet piling, I guess you could have founded piles in them, but the uncertainty associated with that and the even greater risks associated with that were obviously precluded that at the end.
And did we ever find out what the final depth of the silts might be?
Well, we did. We had some indication, you know, it was of the order of 50 metres. I mean, we did prove the basal gravels, but not to the degree of fully understanding their distribution and properties. But yes, there was an indication of where they were, and they were a long way down, basically. Yeah.
Just to add something for your question regarding the piles in the silt, we did consider that as an option, having sediment reducing piles in the silt at the very early on, but having discussed it with Welsh Assembly, they were not very keen to explore that option because of obviously the risks. So that was eliminated quite quickly. So it's either piles down to gravels at 50 metres or shallow foundation.
Just a quick question on the old bridge. Just alongside, obviously the reason for replacement was to correct the alignment. Was there any signs of distress in the old bridge? I'm just puzzled as to how the 3-arch bridge was managing to sit there on the rice pudding skin.
Well,
Yeah,
well, I mean, that's the point. It isn't a rice pudding, is it? I mean, that was the issue. When we looked at it originally, one of the points we considered was the fact the existing bridge appeared to be behaving reasonably, but there was a sort of a counter argument to say, well, there might be very specific reasons for that. For example, the existing bridge may have been built on a previous structure, so the ground had been preloaded from that, and this new structure maybe was constructed over a couple of years, which is quite a long time to allow any movements. They could have accommodated perhaps the movements that we might suffer building a bigger structure with different loads over a short period. Those settlements are more problematic compared to somebody who's building it gradually and the thing's one bit settles and he builds it a bit higher. But the conclusion of all this is it isn't a rice pudding. I mean, the ground has behaved pretty stiffly, really, and that those concerns were based, really, understandably, on limited information, the fact that it was a material nobody really understood how it would behave, and some indication that it was a sensitive material or it wasn't a very stiff material from the limited information we had, which, as I say, if we were building something less sensitive, that might not have been an issue, but here it was obviously fundamental if it really, there was a fundamental issue with it. So that's the point. It basically isn't, and it is quite a much more stiffer material than it appears. And certainly we also have the effect of a significant thickness of this gravel, whereby the load is being spread across it as well. So you've got this combination of something which isn't as poor as it might originally appear, and effect of quite a consistent stiff layer of gravels on which to form your foundation. That's not to say that it may not be a material which is sensitive to disturbance, so the logic for not going down the route of driving piles in it probably perhaps still remains. We haven't proved any of that because we haven't excavated into it and seen how it behaved, but in terms of its in situ stiffness, it isn't a rice pudding, was the answer, I think.